Hello. I'm going to talk about this cool project called Verifpal. So you guys use Signal, right? You use TLS, you use WhatsApp. All of these things are called cryptographic protocols. And cryptographic protocols are the systems that are tasked with assuring certain security guarantees like confidentiality for the communications or authentication and so on. So people design these security protocols and they tend to be really complicated. For example, a sophisticated, relatively protocol like Signal has to ensure certain cryptographic properties like forward secrecy. And so it does this thing where it generates new encryption keys all the time between every message. Other protocols like ZRTP have to have certain considerations because they're dealing with voice chat, like encrypted phone calls, etc. And so designing these protocols is really hard. Like, for example, TLS went through many revisions, like 1.1, 1.2, 1.3. And 1.3 was the very first revision of TLS that was designed while actually working together with people who were formally verifying the design of the protocol. So what does formal verification mean? Formal verification is basically, you can basically prove certain things or get assurances about the security guarantees of protocols. Are they resistant to an active attacker? Do they really achieve their security guarantees? So generally speaking, formal verification is kind of an academic thing. And you can see, people use maybe the Z3 theorem prover. There's interesting high assurance programming frameworks like F* that allow you to write formally verified cryptographic primitives and recently protocols as well. There's also modeling frameworks like ProVerif and Tamarin that allow you to illustrate a model of a protocol, like, for example, a model of Alice and Bob speaking over Signal. And then you can ask questions like, okay, this is a model of Signal. Can an active attacker decrypt Alice's first message to Bob? Can an active attacker impersonate Bob to Alice? And so you can sort of get a lot of interesting analysis based on the questions that you ask and the models that you make. Now, many papers have been published on this and so on, but it's not really used a lot. So why is that? Well, it's because it's complicated. Unless you're a specialist in cryptography, it's unlikely that you will be able to really delve into how Tamarin and ProVerif work. So I am working on Verifpal. And so Verifpal also allows you to model and analyze and reason about protocols, but it's really friendly. So it has an intuitive new language for easily describing what Alice and Bob are doing. It has a modeling framework and engine that avoids user error and is easier to use. It even has a user manual that comes with a manga about formal verification, and it's really nice. So please check it out. It can reason about advanced protocols, even though it's really easy to use. It has some advanced features as well. So try it out. You don't have to be a professional or a super extreme advanced person to try it out. Everyone can learn how these systems work and reason about them. Definitely look at the instruction manual as well. The user manual, I mean, it's really friendly and accessible. I strongly recommend that you read it. Verifpal is free open source software. It's very new. I only released it like 2 months ago. And it's still under development, but it's really interesting to use, I hope. It's free and open source software under the GPL version 3, so please check it out at verifpal.com. You can download it for Windows, Linux, and Mac OS today and try it out. Thank you very much.
Thank you.